Hello everyone, I'm John, I'm currently a postdoc, and today I'm really focusing on some points that came out of a study published a few weeks ago on size evolution in fishes that I think will be most useful to macroecologists and evolutionary biologists who are designing a new study. The study itself tested for differences in fish size between the fundamental habitat divisions in water, most obviously between marine and freshwater settings, but as you can see at the bottom, also a variety of others. Now, there are some very good reasons to expect size differences between these environments, and I summarize these in table S1 of the paper. So if you're interested in the detail of the size patterns themselves and their potential drivers, I'd point you to the paper. But today I'm really focusing on those decisions that we're all faced with. Things about what clade you should study or what region, and if you should focus on a hotspot for your phenomenon. Which scale should we focus on, and what taxa should we include and sample? And I didn't really know the best way to go about this, so as suggested by this ancient meme, I just kind of analysed everything I could think of, and those in bold are the ones I address in this talk. So here was the main size pattern in the study, that across many comparisons, freshwater taxa were consistently the smallest, marine and freshwater brackish taxa were consistently medium-sized, and euryhaline and marine brackish taxa were consistently the largest. Now, I really want to focus on the approaches that revealed this pattern and those that could have hidden it, and I'm just going to focus on these euryhaline larger than other habitats finding. So, here's one scale that I looked at. I looked at all families. As you can see, of the 37 families that I examined, 32 of them, euryhaline taxa, were larger than freshwater. Then if you take another scale, the order scale, if I look across all orders, again, it's very consistent. Most clades show euryhaline taxa have larger fishes than freshwater. And then I have a variety of other scales, larger sections of the phylogeny, the full data set, and these evolutionary hotspots, and they all show a very consistent pattern. And there are more in the supplement. Now, what if I compare euryhaline to marine fishes? Across all these scales, across all these comparisons, very consistent picture again. Euryhaline taxa are larger, and the same is true comparing euryhaline and freshwater brackish. So just to say that I found looking at all these different scales and visualizing it like this extremely helpful. And for your question, it may differ. There could be sensible reasons your pattern could vary with scale. Here it was very similar. But now I want to think about how taxon sample might influence the patterns also. Well, the bottom line is that taxa in molecular trees are biased towards larger size in every habitat. Here you can see the molecular tree taxon sample. The red line points to the median, and it's larger than the black line. That's the supertree taxon sample. And it's the same for every habitat. Freshwater brackish, marine, there's a big gap, euryhaline, and marine brackish. And so these may look relatively subtle, but they influence downstream results. For instance, I've shown you this already earlier, that euryhaline taxa are larger than marine in most clades at all scales, right? But when you look at the molecular tree taxon sample, the pattern is still there, but it's considerably weakened. Right? There's lots of times where there are more results where the marine clade is larger than the euryhaline clade. And that really seems to be a result of that bias. And finally, what about hotspots? Well, I showed you that the typical result is that euryhaline taxa are larger than marine. When you look at the non-hotspot clades, that happens most of the time, but it's less common in the hotspot clades. So hotspots are twice as likely to report unusual results. So in conclusion, it can be useful to explore your pattern at different scales, and the importance of scale is likely to vary wildly with the question you're looking at. For me, it was consistent, and I found this visual quite helpful. Where possible, it can be useful to consider the biases that can exist in your data, document them, see if they influence your result. Some issues could be corrected with use of supertrees or kind of bias-aware subsampling. And I also found it helpful to think about evolutionary or macroecological hotspots and how, because they're so special, they might actually be more prone to show these unusual dynamics. This is an issue that affects many of us, and so I have some suggestions here for dealing with it. So more information on this and many other sensitivity analyses can be found in the paper, and the SI text in particular goes into more detail for these issues. So I'd point you there. Otherwise, so with that, thank you very much for listening today. Thank you.